Hello, everyone. Welcome to our webinar on Git for Salesforce admins, the why, how, and when. It's fantastic to see so many of you here in the webinar today. To give you a brief intro, I'm Tina. I'm from the sales team at GearSet. On today's webinar, I'll be taking care of the admin side of things. So if you have any questions, please post it in the Q&A box, and we'll be sure to answer them as we go along. With me today, we have our panelists, Matt Dickens, co-founder and head of marketing for GearSet, and Jason Mann, head of customer success. Over to you, Matt.
Hey folks, hope you're all having a good day. Just before we get started, I should say that for those of you who haven't heard of GearSet, we're a release management and DevOps tool for the Salesforce platform. We're actually not going to talk about GearSet very much at all today. We're going to focus on the fundamental principles of adopting Git and how that's specifically different for people who are working on Salesforce. Okay, so to carry on with the intros, obviously I'm Matt. I'm co-founder and head of marketing here at GearSet, but before you guys start to disregard everything I say because of the marketing in my title, I'm actually one of the original developers on GearSet as well. So I've spent the last several years living and breathing DevOps on the Salesforce platform. And over to Jason.
Yeah, hey everyone, I'm Jason. I'm head of the customer success team at GearSet. So my role is to make sure that whenever people have questions around GearSet, source control, DevOps, best practices, everything like that on the platform, we make sure we give them the information they need so they can get the most out of the tool. So Matt stole my line there a little bit in terms of living and breathing it, but this is the kind of thing that we really do talk to users on a daily basis. We wanted to share some of that knowledge as part of this webinar today with you all. So in terms of agenda there a little bit, we've done the introductions. As Tina mentioned, we're going to do an overview of everything about the wonderful world of Git. So we're going to talk a little bit about what Git is, why it's important, what the benefits it gives you are, how you can implement it, and that's partly from a practical level and partly theoretical in terms of building a toolbox, building a process, and then implementing it in your team. And a little bit on the end, we're going to touch on when is it appropriate for you to put this in place and what does the future of development on the platform look like. Throughout, if you have any questions, then feel free to put them in the chat. There is a Q&A button you should see somewhere on the webinar link where you can put questions in there. We'll either try and answer them as we go, or we'll do a Q&A session at the end to cover the other ones that have been raised. And the recording will be up after we've done this webinar. So this session will be recorded if you have any follow-ups afterwards. And I think with that, I'm going to hand you over to Matt to talk a little bit about the why.
Sure. Okay, so let's get us started. We're going to basically go right back to basics here. So we're not going to assume any prior knowledge. Just in case there are folks who haven't come across Git or version control before. We'll try and move fairly quickly though and get into the meat of it. Okay, so we'll start with what is version control. I guess first and foremost, it's a tool to help you manage changes of something over time. So whether those are documents or source code to an application, or in our case, your org. I suppose before version control, when you're making changes to a file, let's say you're working on a file as part of your day job and you need to make some changes. One thing you might do is create a copy of that file before you make some dramatic changes and give it a new name. So you'd have a version file.txt, and maybe you'll create a new version file2.txt. So you've got a backup of what was there before, just in case you don't like your changes. So you've got a kind of representation that you can go back to. So that's a good thing to do. It's good to have a history of the work that you've been doing, but creating a new file is quite a lot of effort, especially if you're doing it on a regular basis. You can end up with lots of files, and it's not always easy to track which one is the most recent. It becomes hard to manage. Wouldn't it be nice if it was really easy to create a copy of your work? Wouldn't it be great if you always knew what the latest version was? And I guess even better if you could annotate each of those copies with some information on why it exists, what changes you were made, so that if you need to go back to any specific point in time, you have some additional context. This is essentially the problem that version control is designed to solve. So I guess in its original form, it was something that you would run on your local machine. And when you've made a change to something, rather than having to manually save that change to a new file with a new version number appended, you can just commit that change to your version control system with a message for your future self describing why you made that change. And then your version control system will keep a full history of every single one of these changes that you've ever made alongside all of those descriptions. So that's great if you're working locally on your local machine, but it's also really common for people to have to collaborate with other people on their teams. Again, before source control, people would essentially take copies of these files and pass them around either via email or on disk or some other form, so that their colleagues could carry on working on them and see the changes that they'd made. And this really obviously wasn't a great approach, although unfortunately some lawyers still seem to think it's quite a useful way to work. So the question is, how do you keep track of which version is the latest, especially when you have multiple people working on the same file, and how do you integrate different changes that different people have made to essentially the same thing? Well, the solution is to have a centrally hosted version control system that lives on a server somewhere. So much like the version control system that you might have on your local machine, you could host that on a server. And when you're happy with your changes, you could push them to that server, which means anybody else connected to it can pull those changes at any point in time. So it becomes really easy to share. So now you can see exactly who's made which changes, when they were made, and why they were made, because you've also got that textual context of what they've been doing. But what about if that server goes down or your net connection goes down? That's kind of where distributed version control comes in. So Git is a distributed version control system, and it's essentially one of the modern standard in source control systems. Rather than having a single central server, distributed version control systems give you the best of both worlds. So as a user of Git, I have a full copy of all of the work that I've been doing and that my colleagues have been doing locally on my machine, and I also have a copy on a central server somewhere, which means that everybody on the team has the full context of what everyone's been doing, and we can all share and manage those changes amongst ourselves via the central server. So we can track our local changes and then sync up periodically when we want to pull changes from a colleague. In almost all cases, there is a central server. With Git, you actually don't really need a central server because it's distributed. Everyone's individual machine acts essentially as a host for your version control, but it's really, really common to have a central system as well. This gives you all the benefits of centralized version control and all of the benefits of being able to work locally. So it essentially removes all of those risks from centralized version control. If the central server dies, there are multiple copies across the team, so you've got lots of backups. If your net connection goes down temporarily, you can carry on committing changes locally before pushing them back to the server when you're connected again. So before we get into much more detail, it's probably worth going through a quick glossary of terms here. There are a few terms that we're going to use a lot throughout this presentation. I'll just touch on them real quickly. So firstly, we'll be using the terms source control and version control basically interchangeably. They're essentially synonymous, so don't worry too much about which of those we're using. The next main term is repository. So this is essentially the entire definition of the full history of your project. So it includes all of the files that anyone's been working on. It includes every copy of those files that each individual team member has been working on. It's essentially the central container of all of the work that you've all been doing. A branch is a strand of work that an individual person is working on. So as a developer, when I want to start making a substantial change, rather than making them on the original core set of files, I can take a branch, which is essentially a copy of those files, and I can start making modifications to my branch independently of the work that all of the other developers on the project are doing. This means that any developer can work in their own isolated branches without impacting any other developer. Generally, you'd create that branch as soon as you start working on a feature, which is why branches are often referred to as feature branches. And there's the master branch, which is essentially a special branch. It doesn't have to be called master, but it's a very common term. And there's nothing intrinsically special about it. It's special because of convention. So there's usually a single branch that is what's considered to be the source of truth for the project that you're working on, and that's usually master. Feature branches are normally created from master. So a dev will create a feature branch when they start working on that feature, and when they're content with that feature and it's ready for release, then it'll be reintegrated into that master branch. Next term is a commit. So a commit is just a snapshot of the current state of your project. So all of the files in your project will have a snapshot taken every time you make a commit. So when you make some changes, you make that commit, you give it a description that tells future you and your colleagues what the change you made was and why you made it. And that essentially gets saved out to your source control system. Making regular small commits gives you a really detailed history of the evolution of your project, as well as a pretty concrete narrative for that work that you've been doing. Next up is merge. So this will probably be something that you guys have heard a lot. When a feature is ready, that's essentially when the branch needs to be reintegrated into the master branch, and the term that's used for integrating one branch into another is a merge. And then one topic that I actually want to talk about a little bit more before we go on is a merge conflict. I guess working with Salesforce for a long time has shown me that conflicts are a thing that come up fairly regularly with people that we speak to. Oh, sorry, just before I jump into that, I should explain the terms that we've just expressed in the context of some very common diagrams that you'll see whenever you're researching Git online. So the outer box essentially represents the repository. You'll see that everything else everything else that's happening on your project happens inside that repository. So it just shows that the repository is the single central container for all of the work that you're doing. Branches are essentially the streams of work then. I've put a little bit of a star next to master here because there's a little detail that I've omitted, but for the purposes of today, this is a good way of thinking about things. A branch is a stream of work, master is just an ordinary branch. The commits are the little blobs in the diagram, so each time you record the current state of your work, and a merge is when changes are integrated from one branch to another. So you can see there that there's a branch that someone's been working on with some commits on it, and then that's been merged back into master. So now I'll jump into talking about merge conflicts and conflicts on Salesforce as a whole. So like I say, it's something that we come across a bunch when we speak to prospective customers and longstanding users of the Salesforce platform in teams where there are multiple people collaborating and working in either different or the same environments. There's no way around conflicts really, but there are definitely ways to mitigate them and make them easier. So before we dive into talking about merge conflicts with version control, we'll just talk about conflicts in general on Salesforce. There are a few scenarios that crop up here. Common ones are someone's made a change in a sandbox and then they push that to production and overwrite a production hotfix. Or two people have made changes in different sandboxes. One of those has already been pushed to production via a change set or some other process. And then the second developer is pushing their change to production and they end up overwriting that change. Fundamentally, these happen when people are making changes to the same files. So we've got an example here where two people have made some changes. There's a change that's happened in production and there's a change that's happened in a sandbox. Now, we have the context here for what's happened. We know that two people have made changes in different files, but that's not really obvious necessarily to the person releasing the change or even to you, depending on the size and complexity of the changes that you and your team have been making. There are actually multiple interpretations to this example we've got here. So if we jump into those interpretations, the first one is that the sandbox has had something added. So you can see a green blob added to the sandbox and that somebody else has deployed a change to prod or made some change directly in prod, which means that there's been an addition to prod as well. So we know that the correct solution here would be to combine those two changes, essentially merging the change from the sandbox into the file in prod so that production reflects both of those additions. We have that context because we know for sure that someone's made a change to each of those files. But if you don't have that context, which is really commonly the case, especially as your team grows in size, then there are actually multiple interpretations. So it could be that in this case, someone's added a change to sandbox, but also deleted something that was in prod from that sandbox. So the outcome here would be that we deploy the file wholesale from sandbox, adding the block in green and removing that block in red. Now, these are just two interpretations of what we've demonstrated, but there are more interpretations. As I said before, on a small scale, it can be quite easy to make the right decisions here if you know exactly who's done what work and where. But when you're working with a large team or a large number of changes, it becomes really difficult to manage. So there are some mitigations. Firstly, you can use tools that break up metadata into its constituent components. So for example, Gearset has been doing this for a long time. We break up objects, profiles, permission sets, and so on. All of those large compound files that consist of lots of underlying components, we break up into smaller files. This means that it's much less likely that if someone's making a change to one of those things, somebody else will be making a change to the exact same file. So it essentially handles some of that merging for you. And Salesforce DX has been doing something similar with splitting out custom fields and so on. Another thing that you can do to mitigate this is to migrate your changes into production regularly. So the more changes that you've made and the more changes that your colleagues have made since you've pushed those into the same environment, into production, the more likely it is that you'll have made changes to the same file and the more likely it is you'll have issues merging. So those two things can help mitigate it. They're helpful practices and they can dramatically reduce the frequency with which you hit conflicts, but they don't completely solve the problem. So source control is probably the best way of avoiding conflicts, whether working on Salesforce or anything else. The The reason it's hard to handle org-to-org merges is because there's no history of what production looked like at the point that you started working in your sandbox. So there's no context for what the starting point was and who made changes where. With source control, because you have a full history of all of the changes you've made, you can use that history to make more intelligent decisions about resolving conflicts. So you can look back through the history to the point at which we started work in our sandbox, and we can see that production didn't have either the change that we see that's been added to the sandbox or the new block that's in green that we see has been added to production. We know what production looked like beforehand, and neither of those were there. This means we know unambiguously that the change to the sandbox didn't delete the block from production because it was added after we started work in the sandbox. This is known as a three-way merge because it takes into account both the source, i.e. the sandbox, the target, i.e. production, and then the common ancestor, what production looked like before we made those changes to production sandbox. This is really important when you're dealing with things like changes to profiles, which are obviously huge and have lots of components in them. And it's one of the fundamentally important aspects of using source control. All that said, merge conflicts are still an inevitable thing. This is why you hear the term merge conflicts with source control. This happens when two files have changed in the same place. So in this case, two developers have changed the exact same line in the same file. So even with the history that we have here, we still don't know which one of those two changes is the ideal resulting change. Should production, after we do the deployment, reflect the first change, the second change, or some combination of the two? This is essentially impossible to resolve without a human choosing the desired outcome. There's no algorithm that exists to solve this problem. And the reason I highlight this is that if anybody promises a tool that can automatically solve merge conflicts for you, then I would approach that with distrust because it's not possible. Git's merge algorithm is actually really sophisticated, and crucially, it's really predictable. It won't surprise you or do anything weird or too clever. Obviously, Git's been around for about the past 15 years, and the core of this merge algorithm has its roots in the 70s and 80s. So it's the best solution that anybody currently knows for resolving merge conflicts on the platform. So hopefully that's covered some of the key introductory topics and one of the knottier concepts of merge conflicts, and just given you a primer there. So far, we've kind of spoken mostly about version control in the context of abstract files. Obviously, with orgs, it's a little bit different. So orgs aren't really built from source. You don't have a bunch of source that defines your org that you then compile and build and push to a server to set your org up. An org's a living, breathing thing. So in the case of orgs, you can extract the structure of it in the form of metadata, either directly via an API or by the CLI tooling that Salesforce provides, either using Ant or Salesforce DX. Once you've done that, you can source control that metadata, and then you can push metadata packages that define the shape of a particular part of your org. So rather than starting from an empty file on your local disk, you'll start by pulling all of the metadata from your org in the first case, then we'll push that into a Git repository, and that will act as your source of truth. And then as you make changes in different environments, in sandboxes, they flow through your source control system, and then all changes that get made in production should flow from your source control system, but never from org to org or directly in the org itself. It's worth noting, there's a little asterisk there, that not all aspects of your org can be externalized in metadata format. That's just because the APIs currently don't support absolutely everything, but the best solution for those things that aren't supported is still to make a note of them and make those changes manually in the target environment. This is becoming less true as the DX team expands the metadata API coverage, and it's already, in fact, pretty broad and covers 99% of what we speak to people about on a regular basis. Okay, so I think we've gone through most of the basics here. We'll just recap the benefits of source control in the context of Salesforce. So I think they can be grouped into four main sections. The first one is collaboration. So we've spoken about branching, creating feature branches so that your developers can work simultaneously and independently on different streams of work. And then Git's conflict resolution makes it really easy to merge those changes back together ready for release. Having those separate streams of work makes it possible to review changes before merge as well. So code review becomes a fairly integral part of the process when you're working with version control, and generally improves the standard of everything that you release. Also, some of the standard tooling, like some of the Git hosting providers like GitHub and GitLab, they include facilities to make it really straightforward to build code review into your process. The next area, I think, is documentation. So obviously the setup menu will show you exactly what state your org is in right now, and you'll get a little bit of context about who's made what changes. But it can be kind of hard to understand why certain aspects of your org are designed and changed in the ways that they are. So version control, because it lets you annotate every change your team makes to your org, and it keeps a full history of who made which change and why they made it, it's useful for all kinds of things. So for instance, auditing, debugging, and so on. The next area, I think, is reliability. So making changes directly in production, I guess, as we all know, is really risky. It's too easy to make a mistake that can impact productivity of teams across your whole company. Version control makes it really easy to make changes completely independently of production, then migrate those tested changes to production when you're satisfied that they're fit for purpose. So you can test them in another environment, in a staging sandbox, and then eventually allow those to flow through to production when you're content the work as expected. This allows you to release in confidence, and in our experience, releasing with confidence always leads to releasing more regularly. When you remove the ceremony from releasing and make it something that's no longer risky, then obviously you can do it much more frequently, and this has all kinds of benefits that I'm not going to go into now. And then the last area, I think, is resilience. So version control should completely capture the structure of your org. So if you ship a bug by accident, you can use your version control system for rollback. If a malicious actor interferes with your org, for instance, or if you make accidental or undesirable changes to it, you can always reconstruct the structure of your org entirely from source control. And I guess this was borne out fairly recently with Permageddon. We saw that teams that were using Git during that period had a much better time of getting their orgs back into their original states than teams that weren't using source control. Okay, so I'll hand over to Jason for a moment now.
Thanks, Matt. So we've gone through there a pretty thorough overview of what Git is, what the benefits are, and how it works. So what I want to talk to you a little bit about now is how do you actually implement this in your different environments? How are you going to put a source-driven development flow into practice? So we're going to cover a few different aspects. We're going to talk about the starting point of assessing your competencies and goals, a little bit about building a toolbox that you can use to then put this into practice. Then we're going to spend a little bit of time actually looking through what's called the Git flow model, which is the most common source-driven development model for Salesforce, and it's a tried and tested one that you can basically take and plant directly in your environment to put this all into practice. A little bit on the end around how to actually implement and continually improving. So to begin with, I want to talk a little bit around assessing your competencies and goals, because essentially putting a whole new process in place, implementing source-driven development if you're currently working in sandboxes is a big project. You're changing people's ways of working, you're implementing new software. It's something that has to be managed to a certain extent to make it achievable. And making sure that you have some considerations and limitations in your mind before you begin is kind of crucial to making sure that the project actually goes as expected and that you can manage expectations and avoid things like feature creep and never-ending projects that just keep going and going and going. So a lot of people tend to come to us as the DevOps experts asking for what is the single best practice template that I can apply to my environment to put source control in. And although there are a lot of well-documented models for how to structure your repository and source-driven process, there isn't a single best practice template that you can just blindly apply to your environment. And the truth is that although you're going to have a basic model to work from, things like your current pain points, what your team structure is, what your dream scenario, your time and budget limitations are all going to factor into what that final process looks like. So you need to think about things like what actually is difficult at the moment. Is it visibility into changes? Is it getting access to the CLI? Is it that we want more automation? Is it that we have change management? Do we need more gating and releasing in our deployments? What about the team structure? Are we dev heavy? Are we admin heavy? Do we have a mixture? What about external consultants or implementation partners? How much of that knowledge can we retain on an ongoing basis after this project is done? And then it's good just to have a think about, if you had a magic wand, what would that dream scenario look like? If you could just magic up a perfect solution, what were those things that you would like to have? And then how are you going to work towards those? And then coming from the other side of that, grounding yourself in reality a little bit, what are the actual key restrictions that you're working with? Does this have to be done in a week? Do you have a year? Do you have very little money, or do you have an endless budget? Because that's going to affect what you're actually going to implement at the end of the day. And all of these factors are going to play around to influence what good looks like for you. Now, I know this sounds a little bit like I'm having a bit of a cop-out here and not trying to give you some practical advice. It's not true. We're going to dive into some really practical workflows in a second, but it's just worth bearing in mind that the process that the Amazons and McKessons of the world put into place for source-driven development are not necessarily going to be the same as the one-man consultancy shops or the smaller startups in the world. So the first idea of once you've got your process mapped out at a high level is to start to build a toolbox. And this is going to provide you the tools you need to actually put this process in place. And you can break it down into three main areas. You've got your Git providers, you have your DevOps tool, and then you have a whole pile of supporting tools that are going to be ancillary to that main process. So we're going to tackle them in turn and use our little fisherman here to build ourselves a DevOps toolbox that we can use. So the first question really when you're putting Git in place is which solution are you going to implement? There are a load of providers out there, but the main three are Bitbucket, GitHub, and GitLab. Really, the differences between them are relatively minimal. They're all pretty well-established Git providers. There are certain differences in terms of the UI and the workflow. So deciding between those essentially comes down to a bit of personal preference about your team and how you want to manage it. If you have any doubts or you don't really know where to start, just pick GitHub. That's what we use internally at GitSet. It's the well-respected Git provider, and they will do everything you need out of source control. So we're just going to go ahead and hook that into our toolbox and put GitHub in there. So the next question that comes up is, should you go with a hosted Git solution or an on-premise one? Now, the difference here is hosted solutions, which is the default option for most of the providers, is essentially your standard SaaS model. So you give them a credit card and they provision you a hosted source control system that you can then put your source code into. The other option you can go for is on-premise. So GitHub, for example, have what's called GitHub Enterprise, which is their on-premise offering for the same system. And this is where you're actually managing the infrastructure yourself. So you're looking after the servers, the actual hardware that runs your system, as well as the software on top of it. And in general, it's easier to absolve yourself of as much responsibility as you can when it comes to managing these sorts of systems. It just adds extra complexity, makes it more complex for you to maintain. It gives you more chances for things to go wrong, and even potentially introduce more security vulnerabilities if you haven't have your data center or your implementation set up correctly. So unless you have some incredibly tight legal regulation restrictions, or you happen to have a spare data center floating around that you can just work with, then really it's best to just go with the hosted version of any of these providers and move on. So we're going to take hosted and we're going to chuck it into our toolbox. The third pillar then you're looking at here is your DevOps tool. So once you've got your source control system in place, you need something that's going to replace the chain sets or the ants of the world to actually migrate that metadata and be the interface between Salesforce and Git. Now, there are a couple of different providers out there. So we're obviously coming from GearSet. I'm going to be a little bit biased here, and I think we solve the solution in the best way possible. And because the workflow we're going to talk through a little bit later references GearSet quite a lot, I'm just going to go ahead and hook it into our toolbox for now. The final part that you want to look at is your supporting tools. So these are things that you may use to help support that development process. They aren't necessarily required to actually put this Git-based flow in place. So they give you an extra layer of depth and control with working through things like the Salesforce DX CLI, working with VS Code if you want more control in an IDE, and even things like text editors like Sublime or Notepad++ or anything you want to actually code. What we're going to do is, because we're just going to be a bit greedy, we're going to take all of these and we're going to put them into our supporting tools in our toolbox. So what we've got now is a starting toolbox for how to build a Git-based development flow. We have our GitHub hosted Git infrastructure, we have a DevOps tool like GearSet, and we have some supporting tools like the DX CLI and Sublime that we're going to work with. So now that we have our project in mind and we have our toolbox, the next thing we want to look at is actually how can we implement this model in our org. So what we're going to talk about here is the actual Git flow model. This is where we really get into the meat of things, and we're going to walk through this in a few different steps to try and keep it all manageable. There are multiple different development flows that you can use based on Git, but this Git flow model is by far the most popular in Salesforce, and it just is something that has been tried and tested across multiple different development environments and different platforms. So we use this model internally at GearSet as well when we're building the application and shipping out those feature releases that we make 3 or 4 times a day to our users. And the idea behind Git flow really is that you have a really simple, fast process that is going to encourage you to make frequent small releases, turn features around really, really fast. And as soon as they're ready, you push them out into the hands of your users so you can start delivering value to them. Because at the end of the day, if you have a process that holds changes up for a long period of time, you're not actually delivering any value to your end users here. And end users here is not just external customers, but it's internal teams. If you have a sales team and you need to enable them by collecting more data, well, they're going to be waiting on you to actually release those features. What we're starting with here is we have our concept of our master branch in Git. As Matt mentioned earlier, this is your single source of truth. This is the thing that represents your production environment, and all changes are going to have to flow through master before they go out into Salesforce. So the first thing we want to do when a new user story or a feature request comes in is we need to create a feature branch to work in. And this is giving us that separate copy of the metadata that we can work in without having to worry about the world changing underneath our feet, stepping on each other's toes, or accidentally releasing something that's not ready. So with a tool like GearSet, what you can do is with a couple of clicks, you can just create a new feature branch throughout the UI, give it a name, hit create, and we'll just spin that up for you without having to bounce out to the CLI. That gives you then your separate feature branch that you can work in. Once you've got that up and running, the next thing you need to do is we've got a developer sandbox that we're going to be making these changes in, and we need to check to make sure whether the sandbox is up to date or if there needs to be anything new to push into it before we start. So let's say, for example, that someone else in my team has been working on some changes that I'm going to build on in this next release. I need to make sure that I've got those changes captured in my sandbox first so I can accurately represent them and build on them. So to begin with, you can just run a quick comparison from this feature branch against your developer sandbox, or it could even be a scratch org as well if you're using Salesforce DX. The process is pretty much identical. And then you can do a quick compare to see what's new, what's changed, what do I need to capture in my sandbox so that my starting point here that I'm working from is accurate and up to date. Once you've got your sandbox up to date, it's then time to sit into your fairly standard development flow. So you're logging into the sandbox through the UI, you're making changes, creating fields, changing profiles, creating reports, workflows, process builder, whatever it is. And on a regular basis, what you're doing is then running comparisons from the sandbox to your feature branch using GearSet, deploying those changes as logical grouped commits into the branch, and that provides you with that ongoing tracking over time. So you can see how this feature is being built, you can track each of those changes back to commits, and you're making sure that everything is backed up in your repository as well. So if something goes wrong or if someone else changes something in your sandbox, you've got that feature, that audit trail tracked within the branch in Git. Once you end up building your feature, it's time to actually get it reviewed and released out. So what you're going to do then is you're going to open a pull request. And again, you can do this with a single click in GearSet once you've been working in your branch. And what the pull request is really is a request to say, I want to take my feature branch work and I want to merge it into master so that you can release it out into production. Now, this is where you're actually going to be working with Git. So this is where code review comes in. Let's say you are writing some Apex classes or you're changing the permission model of your org. It's a really, really good idea, and it's kind of fundamental to source-driven development that you get some extra eyes on this before it gets released. You don't want to be the one who accidentally exposes data that you weren't expecting to, or changes the fundamental behavior of your environment. So at the code review stage, your team can come in, they can provide comments and feedback on your work, they can potentially spot security issues, they can help you with bugging and testing, and that all happens before you actually release these changes out. Once you've been through that review process, you're going to merge that PR, and this is where some of the automation comes in. So with GearSet, you can have a CI job set up in a couple of clicks, and we're probably not going to do it on the demo right now, but it is literally a matter of a couple of clicks to create this and set it up and running. And that's going to watch your master branch. So when you've merged that change, when it's been approved by your team, GearSet is then just going to automatically pick those changes up, build a deployment package without having to have any requirement from you. You don't have to build a package file or anything like that, and then deploy them out into your QA environment so they can be tested. At that point, within a few minutes of hitting merge, the changes are in the hands of the testers. You can go through and make sure you're having QA, UAT if you've got different environments down the line. And once you've got the sign-off from them, the process is really very simple because you can have a separate job in parallel, which is actually running a validation against production as soon as that pull request gets merged. This won't actually deploy the changes, but what it allows you to do is essentially have a one-click deploy. So it'll do the unit testing. It'll make sure that you've got everything compiling essentially correctly and is ready to go. When you get the approval from QA, you can just click one button. We'll use the quick deploy feature in Salesforce to really, really quickly move your changes out and get those features into the hands of your end users. And what this process allows you to do is really, really easily migrate that change through. So you can have the feature branch, you get the code review, you merge it, you release it, you test it, you get it into the hands of your end users. You don't have to interact with the CLI at any point here. You only have to bounce out to Git when you're doing a code review. Everything else you can pretty much manage through your DevOps tool, and it makes that process really, really simple. It means that there is a very, very shallow learning curve compared to a lot of other tools, especially when you're coming from working on a change that's back, for example. So a few things I want to talk about on the model before we just move on from that are, there are some key pillars and concepts that really underpin putting Git flow in place. And although there's a fair amount of flex to how you actually implement this in your environment, it's important to bear these in mind at all times, because if you start removing them, the whole thing is going to fall over and end up in a disaster. So the first one really is that this concept of master must mirror production. Essentially, if you don't treat that as true, then you are no longer having Git as your single source of truth, and you have a split one where production is your sort of source of truth, and so is your master branch, and so maybe is your feature branch, and that muddies the waters. It makes it really, really difficult to understand what's the state of play, where are the single sorts of changes that we need to deploy, and how we're going to roll back if we need to in the future. The second one is this concept of ship often, ship small. Feature branches, features, all these things should be released as soon as possible, and they should be isolated into small chunks. If you can isolate out a feature request into a single individual logical group or a thing that you can ship to your users, you should do that, you should merge it, and you should ship it as soon as possible. You shouldn't hold it up on this major other project or something that's been going for months in the background. And the faster you can manage these changes, not only can you get them into the hands of your users faster, but you can get feedback in case anything's broken, and it makes it much easier to not only avoid conflict, but then resolve any conflicts if they do come up. Again, the third one is around all change must go through Git. Essentially, if you have a process where you have this lovely Git flow model, but then half the team still use change sets and push changes directly into production from there, you're going to end up having real difficulties reconciling where is your single source of truth, how do we make sure we don't overwrite these changes next time we're pushing out from Git, and again, this whole process starts to become a lot more difficult. The fourth one is around short-lived branches. Again, this sort of feeds into the ship often, ship small idea that feature branches should not be going for months and months at a time. If they do, then there's a risk that they're going to get stagnant, and master is going to change underneath them a significant amount, which is going to make it much more difficult to reconcile the changes and avoid merge conflicts. As soon as you have a branch, make your feature, delete the branch, and move on. And then the final one is code review, which is just good practice generally, not necessarily just in Git, but whenever you're making changes, you should always get sign off from someone to make sure that everyone is happy with the changes. You have sign off from release managers if you have them in place, or whatever gating you need, and make sure that everyone's happy before changes get released. So we get a few common questions around source-driven development, especially when teams are first getting started. So I just want to answer a few of these now and preempt perhaps some of your questions. The first one is, do I need to use a CLI to work with Git? And the answer is no. With tools like GearSet, which are entirely UI-based, you can interact without touching a CLI ever, even if you're working with Salesforce DX. And even if you don't use GearSet, tools like GitHub, for example, provide a desktop client which allow you to manage branches, push changes, and open pull requests, again, with just a few clicks of a button. So it's absolutely not a requirement that you need a CLI. Another common one is, what do we actually put in Git? Is Git just for our code? Is it for our Apex? Or is it for our configuration or our declarative changes? And the answer is, it's primarily what's important to your team, but it is by no means limited to just code. If you care about tracking changes to your profiles, your fields, as well as your Apex class and your Visual Force, then you should track those in Git. And it can absolutely do exactly the same process for config as well as code. A lot of people, when they begin, ask, well, how complicated do we make this? This seems like a really simple model. We have a really complex environment. Surely we need to make this more complicated to cover every edge case. It's a trap that you should try and avoid falling into, because the more complicated you make a process to begin with, the easier it is for it to go wrong, for people to get bogged down in too many complicated things without actually seeing the value from it. So really what you should do is start with this model, start simple. If you need to add another layer, so if you need another branch that mirrors master, which goes to QA, then add that in, but don't try and cover every single edge case right off the bat, because you're just going to make life more difficult for yourself down the line. The next one is, do we still need sandboxes? The simple answer is yes. Source control does not remove the need for sandboxes. Even if you're using Salesforce DX, you're still going to be using full or partial copy sandboxes at some point in the line before it gets down to release. You're just essentially interacting them within a slightly different way. We often get asked with a lot of teams as well, is Git just for backup? No, really. There are some cases where you might just want to start off by trialing out Git as a backup tool. But if you're doing that, you're losing so much of the value that it provides because you don't get the change tracking, the code review, all the sorts of things that Matt talked about earlier. So Git is way more than just a backup weekly from production into your master branch. And that's kind of thinking about it the wrong way around. And the final one is who do we actually need to get involved in code review? Is it just the devs? Do I just take a step back as an admin? Absolutely not. You should get everyone involved. And because you can do it through a really nice UI, it's really easy to leave comments in tools like GitHub or Bitbucket or GitLab. It's really important that the whole team has that review, and whoever it is who is making the changes has visibility into what the rest of the team is doing. So I'm just very briefly then going to talk a little bit around how do you pick your battles to get this working correctly? Really, if you're putting this whole process in place to begin with, it's a good idea to pick a small isolated project or a small team as a pilot before you roll this out across your entire organization. And that just gives you a chance to test how things are working, making sure that you find any pain points or learning challenges or things that you need to document in a bit more detail before you sort of roll it out across your entire company. And once you've ironed out those kinks, you know what needs to work and what doesn't. You can then go for a wider rollout and really get the whole company involved. And it's also really useful to find some kind of product champion. Find someone from that pilot team who absolutely loves Git. They really, really love the fact that now you can release 3 times a day instead of once a month, and give that person a voice amongst the company so that they can help bring everyone else along for the ride. Because a real challenge for some teams is they say, we are implementing Git. And everyone goes, no, why? If you don't have that buy-in from the team, you're really going to struggle to make things work. So that product champion role is then really important. And the final thing really to think about is this is not a static process. Git and how you interact with it and Salesforce is changing. And especially when you're just getting started, there's going to be things that you don't know, and there's going to be a lot that you can learn from. So it's really important to go to events like Dreamforce or Trailhead or your local admin on dev meetups. Talk to people, ask them what they're doing, find out what other companies have gone through and how they've made their process work for them. Find some best practice guidance. There's loads of Salesforce blogs out there. There are white papers, and we have a couple on our website, especially one around implementing Git-based development. There are YouTube videos, webinars like this. There's a load of information out there to help you understand what does good look like and how can I improve. And then just be prepared to flex. So don't rely on your starting point as an immovable object. Make changes, adapt it, and improve it over time to make it work for you. And with that, I'm going to hand back over to Matt to talk to you about the when.
Okay, so the obvious answer here is there's no time like the present. And hopefully we've conveyed some of the real immediate benefits to starting to adopt Git as part of your workflow. There's a reason that version control is so widespread across every other software platform on the planet. And the benefits there are also true for people building on top of Salesforce as well. Another facet of this is that more and more companies will expect some experience with Git and version control as time goes on. It's probably a good thing for your career to start getting involved with version control and Git. Partially because this is the direction that development on the Salesforce platform is headed. It's not a fad. It's not something that's going to go away. We really see that probably 5 years down the line, it'll be version control and Git will be a very dominant factor in roles that involve building on top of Salesforce. So to expand on that a little, I suppose, as more teams adopt Salesforce and more companies invest more heavily in development on top of Salesforce, then complexity inevitably increases, and that drives the need for version control, as I think we've shown today. Salesforce themselves have been pushing version control as source of truths for a good while now, past 4 years or so since they initially announced Salesforce DX. And my guess is you'll see them talking about it more and more as time goes on. They're definitely investing heavily in this area. Also, I guess another important aspect is version control isn't just for Apex. I know Jason's already touched on it, but to emphasize that, just look at the expansion of the metadata API that Salesforce used to expose the configuration of your org. It's growing to support more and more different types. For instance, changes to the way things like flows are represented via the API, things like that. The intent is that all configuration will eventually be amenable to keeping under version control before long. And I guess then the other aspect is if you're at all interested in any automation, in taking the manual steps out of releasing, in taking the ceremony out of releasing, then things like continuous integration require Git as a first step. I suppose if there are any takeaways from today, I would say, firstly, that Git's a fundamental tool to any improvements around your release processes. It's one of the first things that I would adopt if I was looking to make some changes or improvements. There are a few concepts that you need to be familiar with, but it doesn't really rely on any complicated tooling, and crucially, it can and should be adopted by the whole team. Lots of other platforms have been using it heavily for years, which is an indicator of its value, but it also means that there's a wealth of experience that we can kind of borrow and build on top of when adopting it around Salesforce too. Obviously, we've mentioned that that Salesforce are betting fairly heavily on Git and on version control in general. And it feels like as time goes on, development on Salesforce is going to become more tightly bound to Git and version control. I guess we intended this webinar as a intro, assuming no prior knowledge. So it's gone right from base principles all the way through to some workflow best practices. So hopefully it was helpful and informative, but it's actually the first in a series that we're putting together around Git. So if I could ask you for two things today, one would be if there's anything you'd like to hear us talk about in more detail, then please just let us know. We're still in the planning stages of some of the subsequent webinars, so we're happy to dig into detail on all kinds of things there. And obviously keep your eyes peeled for the next one in the series. And sign up. So I think that wraps up most of what we wanted to say today. So I think now we can hand it over to some Q&A. Let's see if we have any questions real quick. Okay, first question I'm seeing is, can this be done using pro licenses? Yeah, there's no reason that you can't adopt version control with pro licenses. Next webinar, how will you be notified? We can follow up with you folks directly, but also we'll be publicizing it in the same way that we have with this one. So Tina will be in touch. We'll leave things open here for a few more minutes to see if any more questions trickle in. Please feel free to ask anything that's on your mind. Would we be providing another Gitflow model? That's a good question. We do present a bunch of these. So Jason mentioned one of our white papers, which is at gearset.com/resources. There's one on source control for Salesforce. And that covers a few of the basic models. We're happy to cover those in more detail in a subsequent talk as well. If there's anything specifically that interests you there, then obviously please let us know. We'll share contact details at the end of this presentation as well, so you know where to drop those to. But any further questions afterwards, just send to team@gearset.com. Will future webinars have real-time demos within Gearset? Yeah, we actually considered it for this webinar, but we decided we kind of wanted to go back to basics and talk through Git from the beginning in a bit more detail before diving into a demo. And we also didn't want to make it too salesy. We're more than happy to demo Gearset. So if that's something you guys want to see, then yeah, absolutely, we can include that in the next webinar. I don't think yes, please is a question, but I'm glad that you'd love to see that. We'll be sure to do that. We've got a question here. What would be your suggestion on Gearset with multiple Salesforce orgs? I think I need a bit more context around the question, and this is probably actually not the best format to have that conversation. I guess if I make some assumptions, so firstly, obviously most people using GearSet use it with a whole bunch of different environments. Lots and lots of users have multiple connected orgs. I guess it depends what your workflow looks like. So if the question is around having for instance, a staging environment, a staging sandbox that you use as kind of an integration org before pushing out to production. So your workflow is kind of from sandbox through to version control, through to staging environment in a sandbox, through to production. Then there are recommendations there. So I personally look at setting up a CI job on master to a staging environment first, and then have a validate only CI job on master to production that can run validations of those same changes. That way, when a change is made to master, that automatically gets pushed to staging, and you can go and perform user acceptance testing and things like that in your staging environment. And then it will simultaneously be validated against production, so that when you're happy with those changes in your staging environment, you can essentially click the promote changes button, which will then deploy those already validated changes out to production really safely and reliably. So that's one scenario. But obviously, I'm happy to talk at greater length. If you drop us an email at team@gearset.com afterwards, I'd be more than happy to jump on a call and go into more detail on that, or to get some clarification from you, and then we can talk about it a bit more.
And just to build on that, actually, I don't know if anyone's going to be around at any upcoming Salesforce events, but there's quite a few of us from GearSet heading out to Forcelandia in a week, I believe it is, and then Midwest Dreaming the week after that as well. And we're going to have booths, I believe, at both of those events. So if you are coming to either of those and you have any other follow-up questions, then Matt and myself will be at Forcelandia, and then Matt, you're not coming to Midwest Dreaming. I think it's just going to be me for that one.
Sadly, yes, that's true. There's also Dreamforce a little bit further down the line, which obviously might have a bit broader catchment than those two smaller events. So we'll be out there in Force as well. So if you have any questions or you just want to see a demo, then please feel free to come over to our booth there too, and be more than happy to talk. I guess while we wait for a few more questions to come in, one question I have for you folks is, how much detail would you like to see in some of the future webinars? So we're planning a variety of topics, but one of the things that I'm keen to do as a developer by background is to dive into actually using the command line and actually do live demos of using the CLI, and then showing parallels of that in some of the desktop client tools and tools like GearSet. So you can see, I guess, some of those concepts that we've spoken about in the more abstract sense, you can see them firsthand and see the mechanics of them actually working, and how you deal with things like resolving merge conflicts and things like that. Does that sound interesting to folks?
All right, sounds like we've got a fairly positive response to that. So that sounds like something we can build into the future ones then.
That's great. I'm real keen and excited about that. Cool. We'll pop the slide up with the contact details while we wait for a few more minutes for any final questions. I should also say, if you want to contact either Tina, Jason, or me directly, then our email addresses are really straightforward. They're tina@gearset.com, jason@gearset.com, and Matt with 2 T's at gearset.com. Another question, I've also heard about deployments into production should be phased, i.e. config first, then security. How does that work with Git? That's a really good question, actually. We tend to see folks using Git do fewer phased deployments. It's not something we see as commonly. You know what? I'd have to think about how you would implement a phased deployment reliably with Git. That's not an easy thing to answer. I'm gonna have to think about that and get back to you afterwards. But I'll reach out and we can talk about it a bit more. I think just one thing to add to that. We've definitely seen in the past that there's a reluctance for people to use tools to deploy changes to permissions. So one of the common things that we hear about as people start using Git is that they tend to, they're open to the idea of using a tool to deploy config changes. But then when it comes to permission changes, they've either been burned by tools in the past or obviously change sets has fallen short. And they're skeptical about tools being able to solve that problem. I think if you have the right tools in place, then it doesn't necessarily need to be a stage thing, and it becomes much more straightforward to deploy those permissions changes. So I think that's probably why we as a team haven't seen so many folks taking a staged approach when they're using version control. But again, let me think about it a bit more and see if there are any customers or end users that I can speak to that have taken that approach.
All right, I think we're gonna wrap up there. Thank you very much to everyone who asked questions. If you do have anything else that you think of afterwards, then feel free to. One or two more things before we go. If you have enjoyed this webinar, then yeah, feel free to keep in touch with us so that you can follow up on the follow-up series we're going to be running on TLI. Also, stay in touch with us via following us on LinkedIn and Twitter, just so you can be aware of future developments and the webinars things we're doing in the future. And then, if you do want any of the white papers or anything like that in the future, then feel free to contact us, go to git.com/resources, or if you want right now, you can, there should be a raise hand option somewhere within the webinar. If you raise your hand now, we'll try and take notes of it and we can send you copies of those white papers straight to your inbox after the webinar.
It looks like Jason's mic was playing up a little bit there. I'll try and recap, but I'll be honest, I switched off a little bit and I wasn't completely listening to what he said. So I'll do my best Jason impersonation. So I think, firstly, if you guys enjoyed this and you're interested in hearing more about Git and the things that we have to talk about, then please do follow us on LinkedIn and Twitter. We're periodically active on there. So we'll publicize things like our upcoming webinars and things like that in those spaces. And the other thing is, if any of you are interested in receiving copies of the white papers that we put on our website, obviously first you can just grab them from git.com/resources. There's no details wall or anything like that. You don't have to give us email addresses to grab those things. Just feel free to go and grab them. But also, if you want us to email anything to your inbox, then just raise your hands. I think there should be a button to raise your hand here. If you do that, we'll just take a note down and we'll follow up with you to send over those white papers on Git best practices that dive into a kind of, there's sort of a little bit sort of the next step from where we finished up today. And then also, please do feel free to reach out to any of us at any time. We're more than happy to chat. Hey, and I think with that, we'll wrap it up. So thank you all. Thanks everyone who attended. Thanks for all your great questions. And obviously thanks to Tina and Jason here. And we'll hopefully see you on the next webinar.